chapter 2, if you hopefully just taking a quick glance at the learning goal sheet that I just handed out to you, you're seeing that we're going to be dealing with, instead of equations in this chapter, we're going to be dealing with inequalities. Okay? So today our goal is to be able to, it says I can identify solutions of inequalities in one variable, because by the way, you can't have inequalities with more than one variable. We're only going to deal with the one variable ones right now. What?
More than one variable. More than.
That, oh, I get it. No, it's inequality more than. No, more than means what? Doesn't mean an inequality. It means no, it does not. It means addition. Is more than means an inequality. We have to put the word is in there to make it into an inequality. Okay. And then you will also be able to write and graph inequalities in one variable. Okay, so let's start out by graphing and writing inequalities here. An inequality is a statement that compares two expressions, just like an equation does. It's a statement that compares two expressions, but it uses one of these 5 symbols rather than an equal sign. Okay, so we have 5 inequality symbols. What is our first one? That we have a V on its side pointing to the left. What's that? Okay, so make sure you're careful what words it really means. I think I might have heard it from some and others left out a word. What is it?
Less than.
Is less than. Is less than. Really important that that word is there. Because remember, less than, just less than, without the word is means what? Subtraction. So we've got to be careful. We got to know the difference. So is less than. Well, what happens when they now stick a little, like that little bar underneath it, that little line segment underneath that same symbol? What does it do to it now?
Less than or equal to. Is less than or equal to.
Is less than or equal to. You don't have to use the word is in front of equal to. That you can leave the word is off of, but you cannot leave the word is off of the less than part. Okay, now we flip that V over, now it's pointing to the right. Now what does it say?
Is greater than.
Is greater than, okay, is greater than. And again, very important that we use the word is, because otherwise we could say 4 greater than 7, and that is true if you can do that. It's 4 plus 7. But if we say 4 is greater than 7, now we don't have a true statement, because we mean something else. Okay, stick a bar underneath it, it means?
Is greater than or equal to.
Yeah, is greater than or equal to. Now, back in elementary school, probably somewhere, they taught you some little trick or something to help you remember which one is the is greater than, which one is the is less than. Whatever way you learn, hopefully you learn some way, but it's amazing how many students, when I ask them when I'm at their desk and I'm helping with it, and I say, what does this say? And they kind of give me this look like, I hope I guess right. I have a 50-50 chance. We should know what they mean. Get it down. Figure out something that will help you understand which one is the is less than and which one is the is greater than. I don't want you to have to hesitate at all. I want you to be able to read a statement to me and say the words properly and not have to hesitate and go through I'm going to try and guess and hope I'm right. Okay, what's our last inequality symbol say?
Is not equal to.
Is not equal to. That's an inequality statement also. Or a symbol, I mean. So there are actually 5 inequality symbols. And we need to know when to use them, how to use them, how to say them, all of that, okay? So a solution of an inequality is any value of the variable that makes the inequality true. Yeah, it has to make it true. If it doesn't make it true, then it can't be considered a solution. Just like in an equation, we find what value or values make the equation true. Same thing goes for an inequality. It has to make it make it true. Okay, so you're gonna have to do some describing or writing out in words or being able to explain what the variable is representing. So describe the values for the variable that make the inequality true. Remember, we only want the ones that'll make it true. And show the solution on a number line. Now I have my own way of how I want you guys to do a number line. It doesn't have to be really fancy. It does not have to be with a whole bunch of values tick marked on it. I require you to do the number that's involved in the inequality and the integers on either side of it, which we'll practice now too. So what does that one say, number 1?
X is less than 10.
X is less than 10. So if you want to write that off to the side, you can, but that's not really what they're asking us to do. But if you want to write that, you may. X is less than 10. What they really want us to do is describe all the values that X can be.
0.
So can we even begin to list all the numbers 0 can be? Is 10 involved, by the way? Is
No.
10 included?
No.
No, but how about
9.
9? Is 9?
9.
Oh yeah, what about 9.99999999876? What about 9.7236789? How about, 9.0000137? How many, could we begin to list all the values? Absolutely impossible. So what we would say instead is that we're going to describe it as all real numbers. Remember, the real numbers are the number line,
Less than 10.
less than 10. Because we can't begin to name them all. So this is the way we have to describe it. Take all the numbers on the number line, all the real numbers, less than 10, they can be substituted in there for X. They will make that inequality true. Can anybody think of any number on the number line that is less than 10 that would not make that inequality true? So in other words, how many solutions are there to this inequality? An infinite number. Does that mean, if we say infinite, does that mean any number out there? Is that what infinite means?
No.
No, infinite means what?
Continuous.
Continuous. We can't name them all. It goes on and on and on. Are there an infinite number of non-solutions also? And where do they start at?
11.
10. No, they actually start at
10.
10 and go up. So we have a whole bunch of non-solutions also. We have an infinite number of non-solutions or all our real numbers that would not make it true. So we have to make sure that we understand that when we're talking about inequalities, we have a whole lot of solutions and we also have a whole lot of non-solutions. Okay? Number 2, what does that actually say right now as it sits? Aaron?
Y is greater than or equal to -3.
Okay, again, you can write this or you don't have to. If you already think you're so good at this, you don't need to. Then you don't need to write that. That's not what they're asking us to do. Here's what they're asking us to do. Describe all the values that Y can be. So what would we say?
-3 and above.
No, that's not how we're going to say it though. -3 and above. What are we going to say?
All real numbers.
All real numbers.
Greater than or equal to -3.
Yeah. So basically what we do is we replace the variable with all real numbers, don't we? All real numbers greater than or equal to, I just thought of something that we forgot to do in the last one, we're going to have to do it on this one too.
Is.
No, not is. You don't have to do is there.
Number.
The number line, we forgot to graph it on the number line.
Oh.
Okay. So let's go back and do a number line for number 1, and then we'll come back to number 2 and do it also. Okay. So in number 1, all real numbers less than 10. So we're going to make a line. That's And we're going to put a tick mark about, in the middle of it. We don't need 0, by the way. We always feel like we have to have 0 because 0 kind of feels like the middle of the number line, doesn't it? But you don't have to have that. 0 is always on the number line, but doesn't have to show, okay? And we're going to put the integers on either side of it, but we do have to remember on the number line we need to use distance to represent how much distance there really is between the values. And so, oops, I got a little bit close there. I didn't do a very good job myself here. So make your tick marks. You don't have to get out a ruler. I did it again. My board needs calibrating, I think. So you don't have to get out a ruler to do this. I'm going to have to go like there. And what's the integer value to the left of 10?
9.
9. What's the integer value to the right of 10? 11. This is what I want you to identify. We have not graphed anything yet, folks. What? We have not graphed a thing yet.
But
here's what we've done. No, we haven't graphed anything yet. We have identified where on the number line we want to be. Because could we show the whole number line?
No.
No, that's not possible either. So we have to say this is the part of the number line I want to show you, and so that's all we're doing right now. We're getting that picture set up. Now we're actually going to graph it. When 10 is not included, anybody know what we have to do?
Go to 9.99.
Oh yeah, and how are we going to do that? How are we going to go to 9.9999?
Get really close to 10, but don't get there yet.
Get really close to 10, but don't get there. How are we going to show that 10 is not included, apparently? Brenda?
You draw an empty circle.
You draw an empty circle there. You draw an empty circle at 10, and I'm going to calibrate right now because I'm getting really sick of this.
Yeah.
You draw an empty circle at 10, and then you shade. Do you shade it in?
No, you do not.
When would we shade it in?
If it's on 10.
If 10 is included, but 10's not included, so we leave it empty, and which numbers are less than 10? The ones to the left or to the right?
To the left.
To the left, of course, because 9 is. This is how I do mine. You have a way, maybe, but show it shaded. And make sure that the arrow also gets shaded, because we know that it goes on infinitely in that direction, and all those numbers are included also. Okay, now let's go back and do our number 2. Okay? So, draw ourselves a number line. We need -3 in the picture. We need an integer, the next integer to the left, which is
-2.
Negative 4.
Oh, this is how you show me good number line sense. And then we need the integer to the right, which is -2. Have we done any graphing yet?
No.
No, we're just setting it up. We're getting where do we want to be on the number line. Okay, so Blake, tell me, what are we going to do with that -3? Any ideas? Circle.
Do not shade it and not the arrow.
I don't think so.
No, you shade it.
Your table partners are going to disagree with you. Tyler, what do you want us to do?
Shaded because it says the or equal to.
Yeah, because of the or equal to, because -3 is included, we do want to shade it in. This time we want to color that in. And then we're going to shade all numbers greater than that. So we would shade to the right. We would shade to the right. Okay. So any questions about the kind of number line I need to see so far? Okay, then let's do one more here. We have -3/4. What's that say?
Is less than.
Is less than m. Now, there are some students who like the number to be first rather than the variable. It just works in their brain better. My brain works better when I switch it up. I just reverse the whole thing. M is greater than -3/4. They mean the same thing, really. In other words, this one says -3/4 has to be less than all the numbers you put in there for m. This one says m has to be greater than all the numbers you put it, that all the numbers you put in for m have to be greater than -3/4. Okay, so let's describe that. All real numbers, what?
Greater than -3/4.
Yeah, so by reversing it like that, it does make it easier to make our description. All real numbers greater than -3/4. Okay, this number line's gonna be a little trickier, okay, because we're still gonna use integers. Aaron?
Isn't there a symbol for all real numbers?
There is.
Yeah, isn't it like the R
It's
with
a
the
R.
extra line?
It is, but,
It's a lot.
but since we're not using symbols, we're using words.
So you have to write it out for
Yeah,
us?
you do have to write it out instead, okay?
Okay.
Oh.
Yeah, I know.
I will see room space.
Okay, so
See?
-3/4 is gonna be our,
Middle.
kind of like we call it our middle, I guess. But we're gonna put integer values. Here's where you're gonna show me your real number line sense. What is the integer closest to -3/4 off to the left? -1. Okay. What is the integer closest to -3/4 off to its right?
-1.
0. Okay. Well, which one is it closer to?
It's closer to -1.
It's closer to -1. So we're gonna put -1 pretty close to it. And then, how many sections like that are we gonna need to go to the right from -3/4?
2.
We need to go to 0.
Oh, that's like one section away because
This is 1/4, isn't it? This is a fourth of this right here,
then you
from
need to
here
go
to
3.
here is a fourth of a unit of distance.
Then you need to go 3.
So we need to go 1, 2, whoopsie, that's 0, not 1. I'm saying the word 1 and then I've got,
3.
okay. So we have to show that we have good number line sense also while we're doing these,
Yeah.
okay? Anybody have questions about that or not clear why it's such a big deal? Okay, what are we gonna do at -3/4?
You're gonna do an empty circle on -3/4.
So -3/4 is not included, so we
And
leave it
then-
empty.
And then you go to the 0.
And then we shade to the right because the number is greater than -3/4.
Yes.
So let's just check that out now. Let's go back to how it was in the beginning. Let's take that 0 that's in the shaded region and let's put it in here for m. Is -3/4 less than 0?
Yes.
Yes. So it looks like we did an okay job when we even switched it around. Okay, so yes, there is an abbreviation for all real numbers. We're not going to use it. We're going to write it out. And yes, the mathematical inequality symbol is going to be written out in words also when they want you to do describing like this. So in the homework, when the notes say, or when the directions say what our notes said, that's what we will do. Okay, let's go to the back side. Right, the inequality shown by each graph looks like you need your books on to page 103. So now you don't have to write any words, now you get to use your symbol sheet. So we're going to do number 10, it looks like, through 15. Okay, so looking at the graph, what solution, which inequality is graphed in number 10? What's opposite, I think, is the one for that one. Aaron?
All real numbers.
Okay, but you get to, by the way, you get to pick a variable to represent that this time. Remember?
W.
W, okay, W.
So.
I can help you with it.
Well, it's all real numbers less than or equal to -2. I know that, but I don't know.
Okay, so all real numbers is our W,
Oh, okay.
less than or equal to, and what was the number that?
-2.
-2. So they want you, this time they want you to write the inequality that that graph represents. So if you need to say it to yourself as Aaron was first, he said all real numbers less than or equal to -2, All real numbers can be replaced by a variable. An inequality symbol can take care of the numbers that are going to be included. And then where is that starting number at? Okay? Okay, you try them all now. You see if you can do them all. 11 through 15, and then I'll have the answer to you up here in a moment. And again, you get to pick your own variable. I don't think they have anything on there indicating which one to use. No peeking until you're done.
Oh.
And if you want to disagree with any of them, you can do so nicely with your hand up. I will be happy to try to be persuaded to change my mind. So again, how do we know when we should include the equal to bar and when we should not? That's oftentimes a decision. How do we know? If it's a shaded circle, we do what?
Include.
Then the equal to bar is there, isn't it? If the circle is not shaded,
We uninclude.
we do not have an equal to bar in our inequality symbol. When the graph is already graphed, it's pretty, and if you write it with the, here, listen to me carefully here, if you write it with the variable on the left side of your inequality, what holds true to help you decide which way your symbol should point? So in this one, I'm going to guess that this is how.
Oh, it's like an arrow. It's like the, since it's pointing that way.
Is this the way it was shaded?
No.
Yeah. Yes, it was. So like the thing is like an arrow.
It's like the
Opposite.
movie Arrow, isn't it? Oh, no.
Look at if the inequality symbol is pointing. Well, I should have used red because I'm doing this one. Okay. It is pointing to the left. The shading is going to the left, isn't it? Now that is when you got to make sure you're careful about that. That is when the variable is written on the left side of the inequality. You can follow that rule. If it's switched up, then it doesn't hold true. If the variable is on the right side, if you write it with the variable on the right side, then you can't follow that.
Then you have to do the opposite.
Then you have to do the opposite. That's right. Okay. Anybody get questions about any of those? Want to challenge any of them?
I think you're right.
Okay, well then it says we're going to define a variable and write an inequality for each situation and graph the solution. So we're still on page 103, now we're jumping down to number 16. Define a variable means, in other words, pick a variable and say what's it represent. Okay, so would you read number 16 to yourself? Okay, so what should we let our variable represent?
See.
No, you should have M for numbers.
Let's just use X because.
Okay.
X.
X just marks the spot. Okay, X is what?
is,
Greater than or equal to.
No, we're describing the variable first. X is club members what?
needed.
No, club members present.
Oh,
Club members present. We have to be specific. Because there can also be club members that are not there, and that isn't what they're talking about. So it says, there must be at least 20 club members present in order to hold a meeting. So now, Riley, do you want to give us the inequality statement?
X is greater than or equal to 20.
Okay, so there must be at least 20, oh, I didn't do the one you said. You said is greater than, didn't you?
Yeah.
I'm sorry, you didn't listen. Is greater than or equal to 20. Does this say at least is greater than or equal to? At least means, what would be the smallest number there could be?
20.
20. What's the next choice? 21. Can we have 21 and a half or 20 and a half?
no, because I'm
No,
pretty
these are
sure.
people we're talking about, okay? Where, so we have to state that. These are people. So, well, you could, but that wouldn't be nice. Where X is a whole number. Okay, so you have to put this down. This is important also. So when we're describing X, and students lose points for this because they don't stop and think about, you know what, even though we shade it and make it look like we can have parts of people on our graph, we really can't. So we have to say where X is a whole number, or in other words, from our shaded region, only take the whole numbers. So we're going to put a 20, and we're going to put, what else can't we have? Okay, we're going to shade to the right, aren't we?
Yes.
So, but what, if we were going to shade to the left, would there be a place it would have to stop?
0.
At 0, because you can't have
Negative
people, okay? So, we're going to show that we would have 21 here, and we can put our 19 here, and we don't have to worry about going to the left though, because we're going to actually put a closed circle at 20, and we're going to shade to the right, and so we can have 1 million people
in the club.
in a club, sure. It's quite a club, it's a popular club. Okay, so we described our variable, we wrote our inequality statement, we showed the graph for it. Okay, let's do number 17 quickly here. What would our variable represent this time, Sage?
I have a question about 16. Wouldn't it not be an arrow on the left side? Because if you know.
Well, no, we still have an arrow, but we're just not, you know, oh, I see what you say, you want to just stop it at 0 like this? You could do that too, yes, Brendan.
If I just draw a shaded triangle as the thing on the other end.
Shaded triangle on the point as the, so like this, you mean?
Yeah, just a shaded triangle.
I don't know, it depends on what,
No, shade pointing to the right. So
oh, yeah, that works too, I guess, sure. Okay. Well, we need to keep going here, number 17. What's our variable going to represent?
B.
The what?
Oh, it's B. But it's
We're going to use X. X is the what?
it's being permanent.
It's the heart rate, right? Let's just kind of make it short and succinct. X is the heart rate, okay? What else what does it say? It says, a trainer advises an athlete to keep his heart rate under 140 beats per minute. So we would have to say where X is, well, wait a minute. No, where X is what? Can we have a negative heartbeat?
No.
I hope not. Okay, we'd be gone.
You'd be
Okay,
like,
so where X is positive, in other words, we don't even want our heartbeat to be 0. It has to be a positive number. We have to be alive. Okay?
let's hope.
Where X is positive, and then we would say X is less than 140, if I remember right.
You
Isn't
guys
that
want
what?
to less than?
Oh, it says under 140. Would we have the equal to bar there?
No.
No, we would not. Okay, and then, hey, quit packing up. I've told you this at the beginning of the year. If we go into the bell, we go into the bell. Okay, 140. This one can't go, so we're not going to put the other integers. We're going to put a 0 here. And we're going to put, remember, it can't be 0 or you'd be dead. It can't be 140. They want it under 140. So we would shade in between those two. Okay? Now, make sure you get the assignment written down before you leave, and you can go.